Yep, that's me. You're probably wondering how I ended up in this situation.
Ladies and gentlemen, start your engines. It all began 3 months ago when we formed the legendary Group 47, ready to race into the world of robotics. Our mission? To build a high-speed robotics system that could navigate a challenging arena, dodge obstacles like a pro, and recognize images along the way, just like dodging shells in Mario Kart. Today, we're thrilled to present the grand finale of our thrilling adventures. Buckle up and get ready for an exciting ride.
It's almost time for the MDP Cup, but we don't have a card ready yet. What should we do?
Let's start by building our cart. What parts can we use?
We have a bunch of screws, some pillar-looking things, an ultrasonic sensor, and an infrared sensor.
We can work with that. Let's go!
First, we need a spot for a camera. I guess this would do. Next, let's sit our STM32 controller on its throne. We can also add the RPI here later. Lastly, we need to solder a few wires to connect our sensors to the controller, and we're done!
Wow, that's great! Let's figure out how to make our card move now. Let's use the gyroscope to tell where our card is facing. Next, we can adjust our PWM and encoder values for the motors. But this is still prone to mistakes, so we'll use a PID controller to make sure our outputs are accurate. Now we can make our card move forwards and backwards and turn left and right.
Yahoo! Now let's also add some UART communication to let our controller talk to the RPI. Lastly, we need to make sure our sensors have accurate readings so that we can use them for task 2. Now that we have our cart moving perfectly, let's give our cart over to the algo people.
Hey there folks, it's Jing here with my pal Chloe, and we're the algorithm team. Our job, to make sure our robot zooms past all obstacles and reaches the finish line in record time, like a turbo boost on Rainbow Road.
That's right, Jingjie. We've got our hands on the simulator, kind of like a practice track, where we test out our pathfinding algorithms. Our algorithm figures out the best order to visit each obstacle, and then it picks the best route, like picking the fastest shortcuts on the track.
Exactly. The algorithm chooses between different moves, straight paths or tight turns, just like avoiding banana peels. And you know what? We use the A-style algorithm to find the shortest path. It's like using a green shell to get straight to the target. We even use the distance to the goal as our heuristic.
Ooh, and get this! We give our robot an extra 10 cm of clearance in all directions to keep it safe, like a superstar, so it doesn't bump into anything during those tight turns.
Now it's time for a live demo. Watch how our robot speeds its way to the front of every obstacle, avoiding them like a pro.
But now that our robot can zip through the track reliably, we need to figure out what's on each obstacle.
And that's where the image recognition team comes in. They help us figure out what images are on these obstacles.
It's all part of making sure we have a winning strategy, just like mastering every Mario Kart track.
Let's go!
The Raspberry Pi is the engine powering our Mario Kart adventure. The RPI fires up the Bluetooth circuit connecting to our Android tablet, which acts as our kart's navigation assistant. The RPI receives coordinates of the obstacles from the tablet and sends them straight to the algorithm pit crew stationed on the algorithm laptop. Once an optimal path is processed, the RPI sends movement instructions to our kart's onboard system, the STM controller, via a USB connection. The RPI ensures that communication between all systems is as smooth as a drift. To help identify these obstacles, the RPI camera captures an image of the track ahead, passing it to the image server pit crew over RPI Wi-Fi for analysis on the image recognition laptop. The accuracy of our image recognition depends on distance, lighting, and angles, just like trying to spot a shell around the corner. To prepare for anything, we took images from different angles and lighting conditions, and annotated them using RoboFlow.
With RoboFlow, we can fine-tune our system, adding pre-processing tweaks like a slight rotation to account for karts drifting around the corners. Adjusting brightness and contrast simulates racing under different lighting conditions, from indoor stadiums to sunny outdoor tracks. Grayscale processing helps us stay focused on hazards no matter the colorful backgrounds. Now that we've prepped our dataset, we are ready to train our kart AI using the YOLO V8 medium-sized model. We race through 50 laps or epochs to teach the AI to spot everything from Goombas to item boxes. For extra accuracy, we set the flip left-right option to 0, and this ensures our AI doesn't mistake left turns for the right ones. Just imagine getting lost on Rainbow Road. With all systems a go, we are now ready to race on any map, which will be determined by our Android team.
Hi, I'm PREETISH and this is Samuel, and we are part of the Android team. Hey Samuel, so we are gearing up to make this app's UI better than a perfectly timed red shell, huh?
You got it, PREETISH. We're making it intuitive and visually appealing. You know, something that works like a well-oiled kart on Rainbow Road, even on small screens.
Perfect, and to keep it engaging, we even added a Mario Kart themed splash screen to kick things off. A nice nod to the team spirit, right?
Oh yeah, and from there, it's straight to the Bluetooth setup. Quick, easy, and right to the point. Kinda like a shortcut that gets you to first place.
Once connected, users go back to the main screen where they can drag and drop obstacles on the map, just like setting up items on the track. And with a simple tap, they can set the obstacle's direction.
Exactly. And then the robot's starting point shows up. No confusion, just a clear visual. The positions of both the robot and the obstacles are sent to the algorithm team in the best format for their code.
That's right, and when the algorithm finishes its run, we get the green light to move forward. It's all smooth and efficient, just like a perfect lap in Bowser's castle.
You said it, PREETISH. Our design and functionality have to work together like a perfect duo. It's all about giving users a seamless experience, no spinning out.
And with this app, we are definitely gonna cross the finish line in style.
Let's go!